Assalamualaikum and a very good day. I am Najah Batrisha binti Fahmi Zakaria, and in this video, I'll be presenting my final year project proposal titled Real-Time Image Processing of Malaysian Sign Language. It's supervised by Dr. Ruhaila Maskat. Now let's move to the research background. In 2023, as stated by the Health Equity Project, there are around 55,000 Malaysians registered as deaf and hard of hearing that uses Malaysian Sign Language, or also known as Bahasa Isyarat Malaysia, as their native language. As communication is an essential part of normal everyday life, it is particularly important for deaf people to communicate as normally as possible with others. However, they face obstacles in education, employment, and social inclusion due to the public's unfamiliarity with Malaysian Sign Language. To aid in this issue, people have introduced sign language recognition technologies. Sign language recognition technology translates sign language into text or spoken language. There are two types of sign language recognition. The first one is static recognition, where it understands signs without significant movement or hand position changes. And the next one is dynamic recognition, where it is able to interpret signs involving movement and transitions. The motivation for this study is due to the fact that existing systems have limitations in real-time processing and dynamic gesture recognition on Malaysian Sign Language. This brings us to the first problem statement, which is on Malaysian general population's limited sign language proficiency. Most people who have deafness usually face difficulties in communicating, especially between them and normal people, since many ordinary people cannot understand Malaysian Sign Language. This is supported by Khan and others in 2021, stating that the current way to communicate with them is highly dependent on a person's willingness to learn. This is partly why a majority of non-deaf persons hardly understand sign language. According to Royal National Institute for the Deaf Study, a large proportion of British Sign Language users experience trouble interacting with medical staff, resulting in confusion over instructions or inappropriate prescription doses. Furthermore, because of communication challenges, several people avoided attending physicians. Another claim by Abu Abdullah and others in 2021 stated that due to communication obstacles, deaf persons frequently encounter health inequities and have inferior experiences with illness prevention and care. Moving on to the second problem statement, which is more specific to the title of my research, is regarding the inadequate resources for translating Malaysian Sign Language. As said by Khan and others in 2021, even though there has been a lot of research on Malaysian Sign Language recognition in the past, the majority of them has been focused on static sign language with very small vocabularies, which is not adequate for ordinary communication. This inadequacy hampers effective communication since deaf individuals are often forced to rely on specific words or phrases that may not fully express their thoughts or needs. Additionally, the research faced certain challenges, including the limited number of studies on real-time image processing of dynamic Malaysian Sign Language. Most of the existing research on this topic used old techniques and were not user-friendly. To date, there are no existing applications developed for the public in terms of real-time image processing of Malaysian Sign Language, which translates from sign to text, whether in the App Store or in the Google Play Store. Next, let's take a look at the research question for this study. The first one is, what is the most suitable deep learning algorithm for real-time image processing of dynamic Malaysian Sign Language? Second, how to design a real-time recognition model for dynamic Malaysian Sign Language utilizing suitable image processing algorithms. And lastly, how to develop a prototype of real-time dynamic Malaysian Sign Language translator for mobile app. On to the research objectives. First is to discover suitable image processing techniques to be used in developing a real-time dynamic Malaysian Sign Language translator. Second, to design a real-time recognition model for dynamic MSL utilizing suitable image processing algorithms. And last is to develop a prototype of real-time dynamic Malaysian Sign Language translator for mobile app. For the scope of this study, the data will be self-collected videos of myself performing MSL through a webcam camera, which is using OpenCV and MediaPipe heuristics. The study will also be limited to 25 common dynamic words in MSL, which are in the context of patients' clinic visits. In total, there will be 750 videos of 25 gestures with 30 videos for each sign, where each video has 30 frames. The study will also not recognize facial expression of signer and not adhere to any particular grammar rules or order. The study will also not recognize finger spelling methods as they are not included as part of my dataset. For the significance of this research, it is mainly to improve the lives of deaf individuals, promoting inclusivity and reducing isolation. It also aligns with SDG 10, SDG 3, and SDG 9. Moving on to the literature review, this is the literature review map for my final year project that covers the domain, techniques, technology, as well as related works for this project. And this is the literature review table on past research done on dynamic recognition, as well as the literature review table on past Malaysian research done on app development for sign language recognition systems. For the methodology of this research, for the first objective, it involves two phases, which are preliminary study and knowledge acquisition. The second objective, it involves 4 phases, including data collection, data preprocessing, model development, model testing, and evaluation. And for the final objective, it involves 2 phases, which are simulation system development and documentation. Ideally, this is what the expected outcome of this project would look like. In the middle, it is the interface of TensorFlow Lite app for mobile app, but in this example, it is for action recognition. For this project instead, it will recognize dynamic MSL gestures. The left is past research done on sign language detection using LSTM and MediaPipe heuristics, and on the right, it utilizes PostNet. This is the Gantt chart of my final year project proposal depicting the progress flow of my work for this semester, as well as the expected progress flow for the next semester. And these are the references And that is all from me. Thank you.